Hello guys, today we're going to identify the conditions that is needed by a static analyzer in order to determine whether a violation is going to happen or not. Specifically, we are talking about flow-based static analysis, and we're going to determine if a static code analyzer, a flow-based static code analyzer, can detect if the access into this array buff is out of bounds or not, meaning that whether it's access only to the rightfully allocated space or this access is going outside of these bounds, which will cause an error. Now, to summarize, the gist here is a static code analyzer, in summary, needs to have the information available to it at compilation time in order to make a judgment. If this information is not available to it at compilation time, then it cannot make a judgment whether what's going to happen to the code. Not only a static analyzer cannot do that, even a human cannot do that. It's not possible. For example, I'm going to initialize the value of L here using argc. Argc is the number of argument passed to the executable as it is executed in the command line. When the loop iterates and accessing to the array limited by L, not even a human can know whether an access into the array is out of bounds or not, because we cannot determine in advance the value of argc. If the value of the argc is 3, as the executable is typed in the command line, then it will not cause an out of bounds. If it exceeds that value like 10, then it will cause an out of bound access. So in this scenario here, static analysis cannot know. Even a human cannot know because it cannot be known. It is in these conditions, this calls for a dynamic analysis, like unit testing. Let's comment this out and activate line 14. Now this we have here is slightly different this time. Instead of L being initialized to possibly unknown value, RC, here it's being hard-coded to a value of 9. And because this value is known at compilation time, the static analysis can use this information to decide whether there is an access violation or out of bound access into the array. Now let's try to see this in action. Right click. Now I'm choosing recommended rules because this rule sets recommended rules has the particular rule that detects an out of bounds access into an array, among other things also that it does. One of that is out of bounds access. You can see here that indeed possibly accessing array above out of bounds is imminent. 9 is there. There's only 8 elements. All information is available at compilation time. Therefore, the static analyzer can know this. Now, a human can know this because all of the information is flat there, present in one screen. But if the code is complicated, it might not be so obvious to a human. And that is where a static code analyzer shines because it can follow through, gather all the information at compilation time, and if it can make a judgment that indeed this will cause an out-of-bound access, it will flag this uh, time bomb violation is going to occur later on. So let's delete this. So you can see that this is hard coded. Now, how about if the value of L is computed through a function call? So here, instead of hard coded to 9, it now invokes a function called getL, which sums the 4 and 2, which will initialize L to 6, clearly less than the array 8. Therefore, this will not cause an out-of-bound access. Now, there's a subtle concept here. A flow-based static analysis does not produce a binary executable, yet it can follow through execution of function calls, meaning it can sift through all of the nitty-gritty details of a function and still make a valid judgment. So let's try to run this and see it in action. It will follow through the getL, and based on how getL is implemented, the static analyzer, flow-based static analyzer will make a judgment call that this one does not cause an out-of-bound access because 4 and 2 is 6, less than 8. And let's try the opposite. If the sum of that 4 and 5 is 9, greater than the array, it will cause an access into an array outside of its defined bounds. It will result to a violation. Let's try this one in action. And it found the out-of-bound access violation is imminent in this example here. 4 plus 5 is 9, greater than 8. Now, because we sum 4 and 5. How about these? So I get curious. So how about if it's 1 and 1? So the sum of that is 2, less than the 8. But if you see the function that if A and B are equal, then it will return 10 for some absurd reason. Therefore, this one will cause an out-of-bound access detection. And here it is. It's been detected. So what we have seen here that while flow-based static analysis does not produce a binary executable, but it can follow through the logic of a function at compilation time, and if all the information that it needed is available to it with enough information, then it can make a decision whether a violation is going to happen. In this case, whether an out of bound access into the array is going to happen or not. But if we go back to this line here, where the value of L argc is not known at compilation time, then the static analyzer could not make a judgment whether this will cause an out of bound access into the array or not. Even a human could not also make that judgment. So it all boils down to whether the information is present at compilation time or not. If it's not present at compilation time, then the static analysis cannot make a judgment whether a violation is going to happen or not.